Okay, here are the answers to the Unit 7 Assignment 2, Properties of Rational and Radical Exponents. So I'm going to go through this fairly quickly, reminding you of the rules. When you have the same base and you're multiplying, you will add the exponents. So this is 16 raised to the 1/5 plus 3/10. And however you want to combine the exponents, go ahead. I'm going to use the calculator to show you how to do it on the calculator if you do not want to find a common denominator. So I'm going to take 1/5 plus 3/10, turn it back into a fraction, and it'll be 16 to the 1/2 power. This means when you evaluate what number times itself 2 times gives you 16, the answer is 4. Number 2, we have different bases and different exponents. So I'm going to take the 6 and I'm going to distribute it to the numerator of both rational exponents. So this becomes 7 to the 6/3 times 4 to the 18/5. 6 divided by 3 is 2, and 18 over 5 does not simplify any further. 7 to the 2nd power is 49, and we get to leave 4 as 18 to the 5th power. So we're not breaking any math rules. We don't have 0 on the bottom, we don't have a radical in the bottom or the denominator, and we don't have any negative exponents. We're done. Number 3 may be a little different on your homework. So it may be a different problem, but it'll be the same concept. When you have the same exponent and you're dividing, go ahead and do the operation and then apply the exponent. So I'm going to take 486 divided by 2 to end up with 243. Then I'm going to apply 243 to the 1/5 power. So what number times itself 5 times gives you 243? And you can achieve that number by typing it back into the calculator. 243 raised to the 1/5 power is 3. So I evaluated the inside and received an answer of 3. This could not be my final answer because I have a negative exponent. If I move it to the bottom, it becomes positive. And now I can evaluate. 2 times 2 times 2 is 27. Again, number 3 may be different on your homework, but it will be the same concept. Same for number 4. Number 4 may be slightly different on your paper. When you have the same base and you're dividing, you will subtract the exponents. So I'm going to use the calculator and type in 5/6, subtract 3/4. I'll put it back into fraction form, and I get 8 to the 1/12 power. There's no 0 on the bottom, there's no radicals on the bottom, and there's no exponents that are negative. Problem is done. Number 5. Number 5 is similar to number 3, but instead of dividing, you're multiplying. When you have the same exponent and you're multiplying or dividing, you can go ahead and do the operation that it calls for. 2 times 32 is 64. What times itself 3 times gives you 64? The answer is 4. Rio's has to touch. It's not happy. It goes to the bottom. And 4 squared is 16. He's happy. Can I finish up and go back and answer? No, what I told you, I ran out of that. This is next year's. I changed some of the versions. So find number 6. Find number 6 is the same concept. Same concepts. Carlos, if you'd like to go and grab this paper, there's more of them over there if you want to practice. Okay, So I know that 8 to the 1/5 power is not a nice integer answer, just like 4 to the 1/5 power is not a nice integer answer. I'm going to rewrite this. When you have the same exponent and you're multiplying, you're going to go ahead and do the operation. 8 times 4 is 32. Now apply the exponent. What number times itself 5 times gives you 32? The answer is 2. And negative 5 times 2 is negative 10. For anybody that's currently in here, I have this paper over here, and Juan can get it for you. Is Juan in here any longer? Juan can grab this paper if you'd like it. All right. Remember, there's a hidden 2 here. So this is really 363 to the 1/2 divided by 3 to the 1/2. When you have the same exponent and you're dividing, complete the operation. 363 divided by 3 is 121. And this is really like the square root of 121. It means what times itself 2 times gives you 121. Evaluating, the answer is 11. All right. 6th root of 162. I'm not sure if it's a nice answer or if I have to break it up somehow, so let's try. We're going to type in 192 and raise it to the 1/6 power. I know there's an answer, but I'm wondering, is it a nice integer answer? The answer is no, so I need to find a way to break this apart and simplify it. So I'm going to write down, I know 1 to the 6th power is 1. Now I'm going to check out what is 2 to the 6th power. 2 to the 6th power is 64. So let's check. Can this break down using 64? 192 divided by 64 works. So I'm going to break it apart. 6 through to 64, 6 through to 3. The 6th root of 64 I know is 2. If you don't know that, then you plug it in. 64 raised to the 1/6 power. And you get an answer of 2. So this is 2. And again, I know that 3 to the 1/6 power, there's an answer, but it's not pretty. If you did not know that, you plug it in. Since it's an irrational number, I'll leave it in radical form. Number 4. First thing to ask yourself, is 27 a nice root nth root of 4? So I know it's not, but I want to show you how you can prove that to yourself. Take 27 and raise it to the 1/4 power. And you're going to get an answer, but it's going to be an irrational number. So I need to figure out, what do I need to do to get rid of this radical that's currently in the denominator? So 27 times what number is going to allow me to get a nice integer answer in the bottom? So let's write down the numbers of 4. So 1 to the 4th power is 1. 2 to the 4th power is 16. 3 to the 4th power is 81. And that rings a bell to me. I'm going to check and see. 81 divided by 27. 81 divided by 27 is 3. That works. So 27 times 3 is 81. 27 times 3, remember both bottom and top, is 81. So I'm going to rewrite this. The 4th root of 81 is 3. And I recognize this 21 cannot be simplified any further. Problem is done. Number 10, number 11, number 12 are back to those star problems. It's not required that you use my method of showing the star. If you understand it, that's fine as well. So I see there's a front and a back, and this is both in common in the front and the back. So I'm going to say that star is equal to the 5th root of 71. So this is really negative 7 star plus 11 star. Negative 7 plus 11 is 4. And really it's not star, it's 4 times the 5th root of 71. Problem done. Number 11. There's an x cubed. How many groups of 3 can you take out of 6? 2. How many groups of 3 can you take out of 9? 3. So this first group, what's hiding in front is a 1. And I can see from the front and the back, they both contain an x cubed y squared. The order may be flip-flopped, but they have the exact same variables with the same exponents. So think of this portion as your star. 1 star plus 4 star is 5 star. Really, it's not a star. It's an x cubed y squared. Carlos, is this helping a little? Okay. Number 12. We're going to focus on the nth root. In this case, it's the 5th root. So, is 64 to the 1/5, is it a nice answer? Let's check. It's not. It's an irrational number. So that tells me I'm going to have to break it apart. So I'm going to start with, here we go. What times itself 5 times, it's my fault, let me go back here. 1 to the 5th power is 1. That does not simplify anything. 2 to the 5th power is 32. Hey, that does work. This can break into 32 times 2. Now this is going to be your hint. I know the 5th root of 32 is 2. This is your hint. 2 times something is going to have to give you this if this is going to work. So let's divide 286 by 2, or 486, excuse me, by 2. And 486 divided by 2 is 243. So I'm going to break this one apart into the 5th root of 243 times the 5th root of 2. The 5th root of 32 is 2. And some of you may already know that this answer is 3. If not, you'll plug it in. (243 to the 1/5 power is 3. 2 star subtract 3 star. 2 star subtract 3 star is negative 1 star. And really it's not a star, it is the 5th root of 2. Flip to the back. Number 13. I know that the cube root of negative 125 is negative 5. If you did know that, you could plug it into your calculator. Remember to use parentheses. How many groups of 3 can you take away from 3? 1. How many groups of 3 can you take away from 12? 4. Done. Number 14. Okay, so this means square root, or what two numbers multiply to give you 144? The answer is 12. How many groups of 2 can you take away from 4? How many groups of 2 can you take away from 16? How many groups of 2 can you take out of 36? I said take away, and I meant how many groups can you take out of. So you can take 2 groups of 2 out of 4, 8 groups of 2 out of 16, and 18 groups of 2 out of 36. Problem is done. 2 left. Number 15. So in this problem, we're working with multiples of 4. 4, 8, 12, 16, 20, and so on. So is 28 a multiple of 4? Yes or no? Yeah. Makes life easy. So real quick, this is what it looks like right now. And the problem is you can't have a radical on the bottom. So we need to continue to simplify this. How many groups of 4 can you take out of 28? 7. How many groups of 4 can you take out of 8? Problem is done. As a reminder, one of the rules is you cannot have a radical in the denominator. Very last problem. What number is hiding right here? A 2. So what is the square root of 16? 4. How many groups of 2 can you take out of 3? 1 group with a remainder of 1. How many groups of 2 can you take out of 16? 8. Problem is done.